Hi everyone, welcome back. Now we're going to talk about solving linear equations in general in one variable. So there's kind of a procedure here. Kind of first thing you should always do is clear your fractions. Then if you have any parentheses to distribute them, combine some like terms, move variables to one side, constants to the other, and combine like terms and divide by the coefficient of x, and you should get some value. So let's start off with this example, and the first thing we want to do is find something that cancels all that off. Well, that's usually going to be the least common multiple, and that's going to be 6x in this case. So we're going to multiply both sides by 6x. So 6x times 2 over 3x plus a half equals 6x times 4 over x plus 4/3. So what students like to do is just make a cancellation, and they usually do this wrong. Really, the first good step is to distribute to both terms. So we're going to take 6x and we're going to multiply it by 2/3 x plus 6x times a half. This is going to equal to 6x times 4 over x plus 6x times 4/3. And the reason you want to do this is this makes canceling easier. So we have a 3x and a 6x, so the x's cancel, and 3 goes into 6 2 times, and 2 times 2 is 4. Then we are going to have 2 go into 2 once, and 2 go into 6 3 times, and 3x times 1 is 3x. And this is going to be equal to, well, these x's here cancel, and you're left with 6 times 4 is 24. Sorry. Looking for my pen here. 24. And then the 3 goes into 3 once, 3 goes into 6 2 times, and 2x times 4 is 28. Or not 28, 8x. So we get 4 plus 3x equals 24 plus 8x. So now we move the constants to one side, the numbers to the other. So if I subtract 8x from both sides, I will get a 4 minus 5x equals 24. Subtracting 4 from both sides, I get negative 5x equals 20. And then I'll write that over here to finish the problem. And then dividing both sides by negative 5, I get that x equals negative 4. Now, you should always check your answers to make sure you didn't make an arithmetic error somewhere. So let's do that. So let's see, I want to copy this, but we're going to get rid of the parentheses. Bring that over here. Paste it in. Get rid of the 6x's and the parentheses. Bring that over a little bit. There we go. Bring that one over a little bit. And we want to check x equals negative 4 and see if we get a true statement. So when you do this, you don't move things to the other side. You just plug the number in and simplify each side. So in this case, we'll get 2 over 3 times negative 4 plus a half equals 4 over negative 4 plus 4/3. So this will be 4 minus 12 all over negative 24 equals 12 minus 16 over negative 12. And on this side, we will get a negative 8 over negative 24. On this side, we will get a negative 4 over a negative 12. And these both reduce to a third. If you're not sure what I did on this set, please ask me. I did use a little trick here, and I'd be happy to show you that in person. But it's really not the point of this problem. So this checks, so x equals 4 is our solution. Now notice that we just got one value of 4. So this is known, so our example here is known as a conditional equation, because it is true based on the condition that x equals 4. So this is the condition right here, the conditional equation. But there are two other types of solutions you can get besides conditionals. So let's look at them. So types of solutions you can get. You can get one like this last example where they are conditional. These will always look like x equals a number or x equals some numbers. So in later sections we'll have possibly more than one solution. And the solution, just like above, is whatever values of x you get, because those are the only conditions that make that equation true. But sometimes something weird happens. Sometimes all the variables cancel out. And what happens? Well, there's only one or two things. One thing can happen is you get 0 equals something non-zero. So, for example, 0 equals 4. This is always a false statement. And since this is false for any value of x, that means that you have a contradiction, and that means no solution. Identity, you get down to 0 equals 0. So that means that no matter what value of x you get, both sides of the equation are always going to be equal to each other. So this means that your solution is everything for which your equation is defined. So in previous courses they may have just set the real line, but of course not all our domains will be the entire real line. And so identity is better stated as every value for which your equation or function or your equation is defined for. So let's look at a contradiction here. So the first thing we want to do, there's no fractions to clear, so let's distribute. So we'll have a 4x minus 4 minus 2x minus 2 equals 2x plus 7. So I'm going to combine like terms. So the 4x and the negative 2x give me a 2x. The negative 4 and the negative 2 give me a negative 6, which equals 2x plus 7. And then if I subtract 2x from both sides, you get negative 6 equals 7, which is always false. So you don't actually have to get all the way down to 0 equals something else. But that typically is what happens a lot of the time. But notice we can just move the 6 to the other side and get 0 equals 13. And this is a contradiction. So no solution. But really, the contradiction revealed itself right here. So once you get to this step here, you can say, well, that's not true. Negative 6 doesn't equal negative 7. This is a contradiction since all the x's are gone and there's no solution. So really, this step is not necessary. But not false either. Or false in the sense that you can't add 6 to both sides, you still just will get a false statement. So let's look at an example of identity. So I have a fraction here. So notice in this that the domain is negative affinity to 3, union 3 to affinity, or another way to write it is the set of x such that x is not equal to 3. So if this is going to be an identity, it's only going to be an identity on the set because this equation is undefined for 3. So let's solve it. So we can multiply both sides by x minus 3 to clear denominators. And since we're not defined at x equals 3, that's perfectly okay to do. So we get x minus 3 times 2x over x minus 3. So this will equal x minus 3 times 2 plus 6 over x minus 3. So the left-hand side is very easy. These cancel and leave behind a 2x. On this side of the equation, you may be tempted to FOIL, and that's not the best way to do this. You could just take this entire expression and distribute it. and everything will work out the same. And it's easier, and notice that the x minus 3, when you take it to the second term, will cancel. So we are going to get x minus 3 times 2 plus 6, or times x minus 3 times 6 over x minus 3. So you really just want to do this instead of FOILing, because then you can say, well, that and that cancels. And we can simplify this now to 2x equals, and now we can distribute this way as well, so we'll get a 2x minus 6 plus another 6. These two 6's cancel and give you 0, so we get 2x equals 2x, which gives you 0 equals 0. So this is an identity. So the solution is all values in the domain. Which again is negative infinity to 3, union 3 to infinity.